Hello everyone, my name is Timothy Lee Grant, and today I would like to talk about one of the big problems with motivation in engineering. So, especially early on. Now, there are two big issues that people normally run up to when doing engineering. The first is that it's just damn difficult. Engineering is extremely difficult. It's a lot of math, a lot of physics, a lot of very difficult, dense topics and subjects. So that's the first problem. The second one is the one that I want to talk about today, and that is that when you start off engineering, a lot of your classes are not going to be very applicable. So, for example, you are going to have to do about 2 years of math. You're going to take about a year of physics, a year, maybe a little bit less, of chemistry. So, for me, what I did was I did 2 years of math, and then at about 1.5 years into my math, I started physics and chemistry, so I did those together. Actually, I took chemistry a little bit earlier. So, it took about 3 years, right? Because I was working full time as well. So, it took about 3 years, and then at the end of that 3 years, what could I do? I in math, there's not much that's actually based on the real world. In calculus 1, you are going to be able to determine the slope of a tangent line. Integral calculus, you are going to be able to analyze the area underneath of a curve. Let's see, what was Calc 3 was infinite series and sequences. So you're going to be able to add up, figure out if a series diverges or converges, or what's going to happen with a particular series. I think we did Taylor series as well. After that was multivariable vector calculus. Okay, so you're going to be able to, the gradient vector, you're going to be able to find how to move up a mountain with the greatest ascent, right? Let's see, linear algebra. Honestly, I can't even remember what. I remember doing matrices and trying to figure out vector spaces and stuff like that. I can't remember too much of that. So, right? Differential equations was, in my opinion, the most fun out of the math classes. I really enjoyed diff-EQs, but what can you do with it? Okay, you can analyze uh, the amount of salt in a lake if there's fresh water coming in, or if water with a particular concentration of salt and water going out of the lake, and you can analyze the population of predators and prey and how they depend on each other, so you can do stuff like that. And then in physics, what do you learn? Okay, in the first term, you learn about how a ball falls, how long it takes a ball to fall, right? Or if you give it an initial velocity in the x direction, how far is it going to go? So you can break it up into the x and y, and then analyze, okay, how much time is it going to take for that ball to hit the ground, and now during that amount of time with that initial velocity in the x direction, how far is it going to go, and now you can analyze that. Second term is like springs and circular motion. Third term is electricity. So at the end of those 3 years, I was working at a company. It was a tech company, but I was a technician. So my job was to fix a lot of the robots that went whenever they would have a problem. So I helped maintain the robots that built the product, or more specifically, that tested the medical devices, which that was what the company produced, was medical devices. So there has to be a lot of testing, and the robots assist in those testing. So my job was, if a robot went down, to go fix it, figure out what was going on, why it went down, get it back up, and just to run the robots and stuff like that. So I learned a lot at that job, a lot of troubleshooting, a lot of maintenance of systems to make sure that they will run into the future. And I learned a lot of practical, real world skills. So I would regularly come into the issue where people would ask me, or not, maybe not directly, but they would be wondering, like, what am I able to do now because I've been in school for so long? And I would have to almost answer not that much, because I hadn't learned anything that I could actually apply to the job that I was doing, or anything really. So it was a little bit disheartening, because I would not be seeing a real application to what I was doing. But this really does go away once I started getting into my circuit analysis classes. It's a sophomore level class. It's Circuit Analysis 1. During that term, I was taking that class, and what was the other? Programming. So both of these are very applicable, very useful, and really were able to start letting me see that there is application to what I was doing. So with programming, obviously now at my job, I am able, or was, I'm not working there anymore. I'm a full-time student now, thankfully. But with programming, I was now able to go in, and if there was a problem, I might be able to try to see what the program is doing, to try to figure out what input it's expecting. Then, if I know what the input it's expecting, I might be able to see why it's giving an error. So that was programming, and then once I get better at that, okay, now maybe I can start doing my own programs. The circuit analysis, we have test fixtures that test the medical devices. Okay, if there's a problem with this, what's going on? I can look at a schematic and try to figure out, okay, so it's having this specific problem, which it has to do with this area, and then I can look at the schematic and test, okay, connectivity here, connectivity there. Great, so now I can start applying it, and it really does get useful once you start getting into your actual major classes. Before that, there's not going to be a ton of uses, but those classes are extremely important. I'm right now in my electronics class. I'm doing chemistry. You have to know about the way that the doping occurs in electrical components. So specifically, like in diodes, you have N and P type material that are put together, and one has holes, the other one has extra electrons, and so it's chemistry. So I need to use my knowledge that I got from chemistry. Physics is used all the time. Calculus is used all the time. So all of those classes that didn't have immediate application to them are extremely useful and necessary going forward into the classes that have a lot of use and practical applications. So do not try to not pay attention in those or just get by. Don't just try to get by. Just do the minimum amount of work. Now, try to make sure that you understand everything. Make sure that you have a good grasp on it, because it will come back. And if you don't know it thoroughly, then you might have difficulties going forward into the future of the classes that you really need to be able to do well in. So all of your important classes, make sure you do a good job. And I also wanted to talk about something else. So because I was originally at a community college, I would be in contact with a lot of people who were doing it was called EET. It was electrical technicians, or electrical engineering technology, or something like this. And I would be talking with them, and it seems like what they were doing was a lot more practical at the very beginning. So at the very start, from day one, they were doing circuit analysis. From day one, they were going in, analyzing circuits, trying to figure out what was going on, how to build stuff, how to do stuff. Everything was very practical centric. And I remember thinking, like, these guys from day one are doing practical stuff, and here I am. I'm supposed to be an engineer, right? That's my major, engineering, and these people are doing a lot more. They actually have value, have use in what they're learning. And I remember thinking, like, man, okay, what the heck am I doing in engineering if I can't do anything and these people are able to do stuff? So first off, do not fall for anything that has the tech or technology, right? Engineering technology. If it doesn't have calculus, it's not worth your time. Don't do it. I was working as a high school graduate, 18 years old, fresh out of high school, right? I got hired at that tech company to do manual work, and then once I started moving up a little bit, I started going into a more technician based role. I was working right alongside people who had that EET degree, and they had the exact same position as me. Their degree honestly didn't make very much of a difference. I remember my boss, he came up to me and he's like, "Wait, you have a 2-year degree, right?" I said, "Yeah." And he asked, "Oh, is it the EET degree?" And I said, "Oh, no, it's just a road marker kind of degree that the college gave to me once I had enough credits. It's not really in anything specific, but I'm going for engineering." And he knew exactly what that meant, and he said, "Oh, okay, cool." So even so, don't anything that has technology or doesn't require calculus, it's not worth your time. Don't do it. Get an engineering degree, okay? And if you are doing an engineering degree and you're looking at people who are immediately doing stuff that's practical, don't worry about that, because the practical stuff comes. It comes up once you start getting into your actual major classes. You're going to have to do a lot of base work because your major classes are going to be very difficult, very in-depth, and you are going to have to understand the underlying concepts, whereas the other one, they don't need to understand the underlying concepts as much. It's just go and build something. And so this is the video that I wanted to make. If any of you guys are in that position or about to start engineering, do not get disheartened by the fact that it's not extremely practical at the very beginning, because it becomes very practical. Your upcoming classes are very useful, and eventually you become extremely valuable and capable of building stuff, even if you want to do something as a project on your own time. I have a lot of friends who they just graduated and now they have a whole bunch of time that opened up because they don't have to spend so much time at school, so now they're doing a whole bunch of projects on their own. And yeah, so you're going to be able to do practical stuff. Don't get disheartened by that and keep on going. Alright, so thank you guys for watching this video. If you enjoyed it, please subscribe to this channel, and I will be back very soon. Alright, see you guys.